In this video, I'm going to show you how I built these giant folding doors for an off-grid cabin.
Ow!
Hey, I apologize if the audio is not so great. The white noise you hear behind me is actually the creek down below, and there's just nothing I can do about the creek flowing. My process for building steel frames was pretty basic. First, I measured the opening diagonally from corner to corner, made sure that it was square. Then I measured floor to ceiling and side to side, divided that by 4, and started welding up steel frames. All right, to start off with, we'll talk about the materials. These doors are made of 2.5 inch by 2.5 inch square tubing with 1/8 inch walls, and to that I've welded a 3 inch flat bar. The window frames were one of the last parts of the construction, and so after the beams and the basic structure was in place for the cabin, I used this big open room to weld up the steel frames for all of the windows. After solidly tack welding the frames together, I stood them up in place using block and tackle. And because I'm using a 1/4 inch clearance all the way around, things came out with a pretty good fit. The track that the door rolls on is a 4 inch by 6 inch angle iron with 1/4 inch thick walls. The steel track beam is 20 feet wide, and it's bolted to the main floor beam across the face of the cabin. To help distribute the weight of the door, I had a metal shop curve this 3 inch flat bar into a 5-foot radius. I reinforced the underside of the deck to carry the weight of the rolling door. I welded up this little doghouse to protect the stainless steel roller from the elements. And on the back side, I applied a couple of bolts that allow for up and down adjustment to carry the weight of the door. Because the first door is hinged to the outside wall, it has a fixed pivot, and that means that this roller is not going to change direction. It just rotates in a constant axis around that hinge. The caster on the inside leading edge of the door, however, it needs to pivot. So it's got a pin that follows up inside to allow for the change of the door angle.
This image of my test build shows the full stack. From the bottom, we have the angle iron foundation, the 1 inch angle iron for the track, stainless steel V-groove wheels with a welded pivot bracket that rotates inside a tube sleeve, and I welded that into the door frame.
And we're opening the new doors.
To weld the frames and stand them up, my brother gifted me 5 days of his life. I don't think there's a price you can put on that.
The biggest mistake I made in this project was not understanding that the hinges would not be aligned on the door frames. This one, all the way up on the inside of the door, whereas this one is on the outside of the door. To compensate, I bent the track that the rollers are running on, and you can see right here, the differential is 3 inches, the same as the width of the door. And as the track rolls along, it allows the bifold doors to go completely flat. To lock the doors tight, I use a cam action device called a draw hook. It uses a hex head wrench, and when you rotate it, the hook comes out and then it pulls in to secure the door. On the inside of the door, we attached a leather strap to pull it in, and then from there you can see the pin, as I rotate the handle, draws the door in tight. I really wanted to maximize the views to the outside, which is why I went with the 3 inch flat bar to hold the glass in. However, the glass manufacturer disagreed, said I needed at least 1 inch of overlap. Well, to compensate, I came up with this 1 inch plastic stripping. I just bought UV resistant sheets, had them stripped, cut down into 1 inch lengths, and then we lined those inside to hold the glass in. Hits the rubber stops.
Nice and snug, not too snug.
And away we go down the trolley line. The glass zip line. The
Because the cabin is on a boulder pile and has 20 double pane windows, I built a trolley line to move the glass in.
Three.
To ensure the glass was sized properly, I cut 1/4-inch paneling to fit every opening. I then moved the panels to the glass manufacturer so they could use them as a template. Each of these double pane tall sheets weigh about 170 pounds each, but these guys make handling them look pretty easy.
Here's a look at the finished and sold glass with mitered aluminum angle corners, rivets every couple of feet. You can see here the rivet is riveted directly into the square tubing, and then the finished glass trapped between the outer flange and the inner aluminum angle bar. You're probably wondering how this glass fares in the wintertime, and I'm pretty happy with it. It's a 1/4-inch glass with a 1/2-inch air gap and then another 1/4 inch for a total of 1 inch of glass. We get down to 18 degrees, 15 degrees here, and the wood stove keeps us just warm and toasty. So I also want to mention this cabin is at 6,500 feet, and so the air is quite a bit thinner. For that reason, you need to buy glass that has a bleeder valve. It looks like a piece of wire, but there's actually an opening inside the wire, and it gets folded up inside the glass when it's caulked into place into the window frame. Otherwise, if you just bring up a regular sheet of glass, it could explode on the way up with a change in pressure. To manage the air gaps, I picked up 100 feet of this gasket material with an adhesive backing. However, I've had trouble with the adhesive drying up and just peeling off. That said, I also have not had much trouble, although you can see daylight through the gaps. If I did put gasket material all the way up this gap, it became too difficult to close. And frankly, with the wood stove, I've enjoyed having fresh air coming in through that crack, and it hasn't been a problem as far as keeping the place warm. It's been a few years since we built the steel folding doors. At the time, I can tell you the steel was about $600 and the glass cost about $4,000 just on the 20-foot wide section that I'm showing you today. At the same time, though, I did get quotes running around $20,000 to $30,000 for stacking glass doors or for commercially made bifold doors, 20 feet wide, 14 feet tall. Obviously, that was out of my budget, so that's why I did it myself. Hey, if you like good splinter karma, please like and subscribe. And check out my other videos like the spinning wood stove. Happy building!